So in this video we're going to focus on the equations of motion to help us solve problems. This is grade 9 ASP, and what we're going to do is quickly go over the three main equations of motion that will help you with everything. We'll do a little toolbox method. I'm going to first write down the first formula, which was what we've used up until now. V final is V initial plus AT. The second formula, that's supposed to be an A. The second formula, which I briefly mentioned, was the x equals Vi multiplied by t plus a half AT squared. And the third formula, which I briefly mentioned, is V final squared equals V initial squared plus 2AX. There are more. There's about 5 that are useful, but these 3 will get you anywhere you need. So, from the 3 formulas, we will always need to also know V final, or V initial, A, T, X, displacement. 1, 2, 3, 4, 5. There are 5 variables in acceleration, and we only need 3. We need 3 pieces of information to find the other 2. I only need 3 pieces. And if I have 3 pieces, I can pick one of the formulas. You can see that if I have 3 pieces when one of them is nothing to do with displacement, I can use this one. This one here, if I don't have final velocity, I can use this one. Down here, if I don't have time, I can use this one. So each one will give you a helpful way to get to the answer if you're missing a variable. Okay, so now that we have the toolbox, we can now see what we have. A train leaves a station, accelerates. It accelerates at a rate of 1.6. So if I'm doing this, I would have a little thing written here. I've already got it, so I'm going to write it here. 1.6 is my acceleration. It travels a distance of 800, so that's my displacement or distance, so same. 800. What is its final speed? Which is V final, what I need. I have 2 pieces of information. You might think, oh no, only 2 numbers, 2 pieces? No. The train starts from rest. V initial. V initial is 0. 1, 2, 3. I can use any of these formulas, well, not any of them, because clearly I don't have time. So I need a formula which will get me VF without time. So VF is here. There's time. Can't use that. This one here, well, there's no VF, so that's not useful for me right now. Well, let's look at this one. VF, yes, okay. V initial, I have it. A, I have it. X, I have it. Perfect. I will use this one here. V final squared equals V initial squared plus 2AX. So that equals to, well, that's just 0, plus 2 times 1.6 times 800. And that's for VF squared, right? So if I wanted to find VF, I have to take the opposite of the square, which is the square root. So once I've solved this, all I need to do is take the square root of my answer. You will get 50.6. Over here, we have Miriam driving at this speed here. She brakes and travels this distance. And then what was her acceleration? So again, VF, VI, ATX. She was driving at a speed. So we have an initial speed. We have an initial speed of 20. We have a distance. Distance or displacement, 200. Before coming to rest. Coming to rest is her final speed. This is V final. This was V initial. And then we need to find A. I need A. What do we have now? 1, 2, 3. I need A. So VF, VI, and again, we don't have T. So without T, it's this formula again. So we will do VF squared equals VI squared plus 2AX. I need A. Now, you can do shift solve in your calculator, like I've shown you before, or you can rearrange. Let's put the numbers in and see what happens. VF, that's 0, equals VI. VI is 20, so 20 squared plus, well, it's 2A multiplied by 200. All right, very nice. Now, you can do shift solve to get your answer, or you can rearrange. Why don't we rearrange? I'm going to isolate A. So what I could do is I could take the 20 to the other side. That will become minus 20 squared. I can write that equals 2A times 200. Well, actually, let's simplify it. 2 times 200, that is not an x, by the way, that's a multiply, just in case you think there's an x there. That is 2a, the x is 200. That is 400. So what I'm going to write is just write 400. 400a. Divide both sides by 400, minus 20 squared, whatever that gives you, divided by 400. And if you put that in your calculator, you should get, well, 20 squared is 400, isn't it? So 2 times 2 is 4. Add the 2 zeros, 400 divided by 400. That gives you minus 1. The answer is C, minus 1. Applying the same logic into this one over here, what is the velocity after you travel this much distance? Is it going to be the same formula? I don't know. Let's see. Kind of boring if it is, but let's have a look. V final, V initial, ATX. Let's see. At rest, V initial, 0. Acceleration, 0.5. Velocity after it traveled this much. I need this. X. And this looks like the same thing. I don't have t again. So same formula, this one over here. This time I want the final velocity, so it's literally the same as this idea over here. So I'm going to skip that part, assuming you know it. I'm going to do the same thing over here. So I'll write v final, and I'll just directly go into the square root of the v initial, 0 plus 2ax plus 2 times 0.5 times 4. Doing that, I will get 2. Very good. Now, what's happening here? Initial speed, and it looks like it's the same thing. We have acceleration, we have reaches a final speed, we need to find the initial speed. I'll go ahead and do it because I don't think we've done the initial speed before, so we might be able to need to rearrange. So Vf squared equals Vi squared plus 2ax. Now, this time I put the numbers in, then I rearranged. This time, let's put the rearrangement step first, then put the numbers in, just so you can see how it works both ways. If you prefer to, you can put the numbers in, it doesn't matter, but I'm going to rearrange. I want Vi alone. It's asking me for it. So I will take my 2ax and move it to the other side. This is plus, so of course on the other side it becomes minus. So V final squared minus 2ax. That will give me V initial squared. I don't want V initial squared, I just want V initial. To remove the square, same as before, square root of everything. V final squared minus 2ax. That will tell me V initial without the square. Now, we just simply put the numbers in. We're going to put the numbers in over here. Let's give it a try. V final, it's V final right here. It reaches the speed 60 squared minus 2 times a, which was 1, times 1.6. And that will give me, if you put that in your calculator, it looks like you will get 20 equals 20. 20 is 2 times 10, 1 time. So they're being fancy with it. I take this decimal point, move it back, and if I want to bring it back to 20, I will do times 10 to the 1. That will be 2 times 10 to the 1. If you write that into your calculator, you will see 2 times 10 to the 1, you get 20. Okay, very good. So that's why the answer is A. This one over here, we have this motorcycle with the speeds up to a rate, and again, it's the same thing. So to speed things along, I'm not going to go over it. It's very self-explanatory. We have the distance, which is x. We have a starting speed, which is 4. We have a final speed, which is 6. If you put this stuff into there, you will get your answer for this one. Okay. Now we're looking at, well, more things. And now we're having some other equations of motion, finally. In here, we have a car traveling. So why don't we write V final, V initial, ATX. Okay, traveling at a speed of this. I have the speed of 20. This is the V initial. When you see the ball roll into the street, from the time he applies the brakes, it takes 2 seconds. That's time is 2 for it to come to a stop. So stop, that's 0. Final speed is 0 because it stopped. And then it's asking for the acceleration, so I need a. I don't have x. Out of the 3 equations of form motion we have here, the ones that don't have x is this one here, the simple one. That's what we're going to use, v final minus v initial. What have I done? V final equals v initial plus at. Rearranging it will give you final minus initial divided by the time. So they've already rearranged the formula for you. And you'll get your answer of minus 10. So 0 final minus 20 initial divided by time, 10. Well, negative 10 because negative 20 over 2, which clearly tells me he is slowing down. You can write minus 10. That's enough for you to get the full marks. How far does he go? So now I need to find distance. I have the acceleration now. I have this. This is minus 10. Now that I know it, I need to figure out a formula with this. I can pick any formula I like. I can use I could use the one that we've used so many times, vf squared equals v initial squared plus 2ax. For this one, it means I need to rearrange the formula. If you don't want to do that, we can directly go ahead and get the formula that has the x at the beginning. No need to rearrange. vit plus a half at squared. You might notice that this says x initial. That's the starting. The starting is 9 times out of 10, 0. It won't be until you reach grade 11 where the starting won't be 0 and you have to just figure it out from there. But for grade 9, this is absolutely fine. You don't need to write the x initial. It's going to be 0. Okay, so going ahead and putting the numbers in, well, they've done it over here, but I'll write it again so that it's clear for us to see. I decided not to use that formula because this one is easier. V initial, which is with just 20, multiplied by the time, which was 2, plus a half times minus 10, negative 10, times time, which we have, again, 2 squared. Put that in your calculator, you will get 20, and don't forget the unit, meters. In the short answer, you must write the units. You will lose a mark if you don't, so you don't want to risk losing a mark for nothing. Now I will do this question over here, the final one. Let's have a look. Now we have this, speeding up, very nice, calculate the acceleration. It looks like it's the same idea. So we will do V final, V initial, A, T, X. Car travels on the straight highway, initial speed of 6, okay. Before it speeds up and reaches 22, oh, that's VF I wrote. V initial is 6, V final is 22. And then what? It speeds up at this rate. We have an acceleration. No, we have a time, however, that is 8 seconds. There's the time. The units help us figure out what it's talking about. Find A. So I need A. VF, VI, T, A, same as above, same formula. You can go ahead and see it from here. This time they started with the rearranged version, and this time they did it the way I did it. They had the original equation and then they put the numbers in. So either way, whatever you're comfortable with, you can go ahead and solve it that way. V final was 22. V initial, not V initial, was 6. They've rearranged it for some reason. I don't know why. Let me write it again. V final equals V initial plus AT. I want to know, well, I know the V final is 22. V initial, I know, that is 6. Plus A multiplied by 8, which is why they wrote 8A. A times 8. Rearrange for A. Shift solve for A. Do whatever you want. You will get 2. How far does it travel? And in this one, they also, like me, did not include the XI. So I'm guessing they copied and pasted this from different sources. How far does this travel? Well, that's what I need to find here. I have just figured out A. I know A now. That is 2. So, same thing. I use the same formula as above. Same formula. VIT plus a half AT squared. 6 times 8, that's VINT, 6 times 8, plus a half times 2, which is A, times T, squared. Where is T? 8 squared. And you will solve it and you will get this number. So that's how you do it. I didn't want to go over the same thing again, just to keep the video nice and short. Thank you.